In recent times, or within the past 2 or 4 years, there has been a general wave, a recent trend in the rise of what we call foundational models for robotics. So we have companies that are specializing, deploying, or building robots or making research on foundational models for robotics. And we now have a new term that is now popular more than before. We call it embodied AI. So for an observer, they can ask, what is embodied AI? How is it different from the AI we used to know? And how is it different from robotics? And that is what I want to answer in this video. Just stay tuned. The question now is, let us start with robotics. We have robotics on one hand, we have AI on the other hand, then we have what we call embodied AI that is becoming more popular. People are now using more often than before. So what are the intersecting lines? So let us start with robotics and give us a general idea of what an actual robot is. Although within the scientific industry or the academics or robotics industry, there's no consensus of what a robot is. But we do know, or the definition I'm going to be using in this video is a machine that is able to move from one point to the other or move items from one point to the other. This particular machine that we talk about needs to be able to sense, think, and do what? And act. So once you have a machine that can sense, which means it can look at its environment and determine what it sees, whether it is getting camera, whether it is sensing where it is in the environment, whether it is checking the temperature of the environment. So all these are sensing activities. Then it needs to be able to plan or think like a brain of the robot. So which means there should be something something doing computing on the robot. Then it needs to be able to act. So when we say act, it means your robot needs to be able to move from one point to the other or move things from one point to the other. For it to move or for it to act, it needs what we call actuator. So actuators are motors, DC motors, servo motors, stepper motors, those kind of motors. These are what is going to make your robot to act. So any particular machine that you call a robot needs to have these three things working together: sense, think, and act. So it needs to be present on the robot. So we've had all these things in the past. And as a matter of fact, even when you look at the industrial arms, in the industrial manipulators, the manufacturers usually make these robots. It has ability to think, it has ability to act. But what we see is that eventually when people buy them, they eventually add camera, they add force sensors, different type of sensors to the robot so that it can do whatever we want it to do. But that is not where we are going. We have that. So from time immemorial or within the past decade, people have been using cameras, for instance, on the robots. And when they use cameras on robots, what happens is that for that camera to be smart, for the robot to know what is coming from the camera, then it needs to they put some computer vision algorithm. So this computer vision algorithm is going to allow the camera to allow the robot to know what it is happening in the environment. So whether it is a stop sign, it's determine whether this is an human being or this is an object, what should I do, and those kind of things. Usually these computer vision algorithms they can be deep learning algorithms. So by the time you are going to the deep learning algorithms or whatever algorithm you put on your camera, now you are beginning to apply AI on your robots. So the point is, AI has always been applied on robots, whether within the sensing aspect, the thinking aspect, or even the actuation aspect. But it is not just taking the center stage. People working in robotics and they may not be working on AI at all. So it is just a tool that has been used in robotics. So sometimes also people use what we call reinforcement learning in robotics. So they use it at the control aspect of the robot. Maybe you want to teach a robot how to walk and those other things, and the policy you want it to use, or maybe you want the robot to self-balance and those kind of things. These are ways in which robotics have used AI in the past. What we are now seeing in recent time, within the last 2 or 4 years, immediately ChatGPT became more popular. The LLMs, they became more popular. Now scientists too that are working actively within the robotics field, it began to gain more interest that, okay, what if we can develop what we call foundational models for robots? So the same way we have foundational models for LLMs, large language models, like the Llama from Meta, the GPTs, O3, O1, all these models, the same way we have them for language. Can we have the same for robots? And one of the most popular one that we have, we call it VLA, Visual Language Action. So these VLAs, they are going to allow end-to-end, you apply AI end-to-end for your robots, such that your robots can now become a general purpose. The idea is to have what we call a general purpose robot. Because what we have had since is what we call special purpose robots. So special purpose robots is like, for example, the Roomba cleaning robot is a special purpose robot. It has been designed to clean, and that is what it is going to continue to do. It is not going to become more intelligent and start doing the chores of folding clothes for you. So also, if you design a robot or you make a robot to pick or to palletize, or it cannot just decide on its own to now start doing welding without having to retrain it and customize the whole environment and the whole robot for that particular task. You design a robot to pick and place items. It cannot start to do chores and fold the clothes. So these are different tasks that require different type of specialization. What scientists, what engineers, innovators, what they want to design now is what we call general purpose robot, which means my robot can now fold clothes now, do the chores later, then clean the room, then take an item from one point to the other without having trained to do it before. Whether it has done it before, or it has not done it before, we don't want it. So we want it, we don't want to care about that. We just want to say that, okay, can my robot that have that level of intelligence such that I can put about 5 or 10 items on a desk, and my robot has not seen these items before, and I'm going to tell my robot, okay, can you pick up the book and put it on the shelf? And the robot is going to be able to do that. So companies that are working on this kind of thing, they have termed themselves, they call it foundational models for robots. So that is what they are designing. And people now began to say embodied AI, embodied AI, embodied AI, which means AI that is embodied, because AI necessarily does not have to be embodied. It doesn't, but AI is something, AI like ChatGPTs, these are models that exist. They are not something you can touch physically. But what embodied AI is talking about is it has to be embodied, something you can see, you can feel, you can touch, something physical. You are applying AI to it. So now we know what AI is, we know what robotics is, and embodied AI is just AI that you can apply, physical AI that you're applying to physical systems. Like I said, we've been applying AI to robotics through computer vision, through reinforcement learning in the past. But what we now have now is companies that are busy developing foundational models. They've termed themselves as embodied AI companies. Journalists are using it, science journalists are using it, commentators are using it, and when they say embodied AI, they are referring to these special categories of companies. They work on humanoid robots, developing end-to-end training pipeline, such that robot is going to be trained on language, is going to be trained on different visions, is going to be trained on different multiple types of robots, and they are going to be intelligent to be able to do these diverse sets of tasks. So that is what we call embodied AI. So examples of companies is Tesla has its own company that they are developing foundational models. Google is doing it. Meta is also having some interest. We have Figure AI, and a couple of other companies like that developing and working within the space of foundational models for robotics, terming themselves embodied AI companies. And that is that on the general trend that we are seeing. And in some other time, I'm going to be talking about some of these things and how we can apply it and the market analysis. Okay, thank you. See you.